but okay. All right, we are recording. Here we go. Hey, folks, if you don't have your calculators handy, get them out right now because we're going to be using them a ton today. Also, I should point out right now that on Google Classroom, I have posted keystroke by keystroke details on how to do what we're about to do today. I don't think anyone in this room has a TI-83. I don't think so. I think everyone's 84s. If you are a Casio person, I'd fire up the Google machine and ask it how to do what we're doing in just a minute, because it's not hard on the Casio, but it is different, and I don't know the pathways. So Google it, you'll find it. I've had kids use it in the past. They've done fine. NumWorks, same thing. We'll figure that out if anybody, I have one student with one of those. All right, so let's talk about linear regression. The big idea today, we're trying to find lines of best fit. Okay, now we're going to use our calculators to do this. You can do this process by hand, like in AP Stats. We do this on a really small scale. It's a bit tedious. It's not hard. It's not complicated math. But if you get lots of data points, it gets to be a lot of computation. So that's what calculators and computers are really good at doing for us. Okay, a little definition, a correlation coefficient. It's the letter R is what we use there. I know, I get it. Okay, I don't know why R. Is a measure of how well the data set is fit by a model. R is always going to be between -1 and +1. If you get either extreme, +1 or -1, that means you have a line of best fit that exactly hits every single point, okay? So that would be a perfect linear relationship. -1 or +1, that's a perfect linear relationship. If you get a +1, that means you have a positive slope, like a positive correlation. If you get -1, that means you have a negative slope, which means a negative correlation. I should point out that R is not the slope. So if you get like R equals -0.75, that doesn't mean the slope is -0.75. That means essentially that the fit we would put as a 0.75, and the negative tells us that there's a negative correlation, so it trends downward, okay? The further the number is from 0, the better. If your number is like, here we have R equal to 0, if you have that situation, then you really don't have linear data to work with. Okay, onward. So we're gonna make a scatter plot. I'm having a little pen issue here. I'm trying to fix it really fast. This is driving me crazy. I've had to do it so many times. All right, and hopefully that, oh, is it really doing that to me? I think it's the other one. Okay, we're gonna try it and see if that fixes the issue. Good. Okay, but we're gonna use our calculators to do this. Here's first thing I want you to do, just as before we even get started, I want you to go into mode. Okay, so hit the mode button. It's next to second, and we're gonna scroll down to where it says stat diagnostics. Okay, most of you, it'll be on the first screen. Some of you may have to scroll to page 2 if you have the fatty 84, it might be on page 2. Okay, but we need stat diagnostics to be turned on. So just go over to on and then press enter to highlight it and you're good. Okay, stat diagnostics, we want to be turned on. Okay, I don't care about the clock. No, I wouldn't change anything else here, but turn the stat diagnostics on. Okay, then I'm going to do second and quit to get out of that. Okay, once the stat diagnostics are on, that'll save me a step later. Okay, what I'm going to do next, I'm going to hit stat. You see the button that says stat? It's red now on my calculator. And then we're going to choose the option to edit. And I'm going to enter and list L1 the points, or sorry, the minutes that have been played. It doesn't tell us the name of a person, but you know, whoever. You go stat and then just press enter, basically. Guys, anywhere along this process, if you are getting lost, please tell me. except for Casio people. Sorry, I can help you later. I can try. All right, so enter the minutes played on L1, enter the points scored on L2. All right, now again, I want to remind you that I have all these instructions keystroke by keystroke on Google Classroom. So if you're working on this at home and you get stuck, go look at those instructions. It shows literally every keystroke. For right now, though, just follow with me. Do I need to give you more time to enter L1 and L2? Anybody still working on that? Okay. Here's the process once we've got our data entered. Okay, by the way, it probably goes without saying, but I'm doing a quick double check. Make sure your numbers are right. It's really easy, like to punch in one wrong number and have it mess up all the data. And so you want to make sure, I know that sounds silly, but it's like when your first grade teacher said you have to make sure you copy the problem down correctly or whatever. Maybe that's not first grade. I don't know. But same thing here, get the numbers right, or the whole thing goes haywire, which really shouldn't be too surprising. All right, so what I'm gonna do is I'm trying to think the best way to do this. I'm gonna go to table set, which is second and it's above window. And I hit the wrong one. It's not that one. It's a stat plot above y equals. That's the one I wanted to go to, stat plot. Okay. I just hit second at stat plot. Like I was in here and I just went second Y1 or second stat plot and I'm there. All right, we're going to use plot one. We shouldn't really ever need to use multiples, at least not in this class. But I'm going to hit enter on plot one and I'm going to turn it on. And then honestly, everything else that's here is fine as it is, okay? The type, it's the first one, it's scatter plot is what we want. We don't want it to turn it into a bar graph or a box and whiskers or anything like that. We want the scatter plot. So we just want our points. Okay. Once I've highlighted on, I'm going to do one more thing and then we'll go and find the regression equation. I'm going to hit the y equals button. I want you guys to do that too. You should notice two things that you'd be looking for on your calculator right here. One is that plot one is highlighted. Do you see that on yours too? If it's not, you can actually turn on just right here. You can toggle the plots off or on from this screen. So like right now, my plot one's not on. I can just go up there and press enter and it's on, okay? And as long as you don't change the settings in your stat plot area, then you should be good just to turn it off and on from here, okay? The other thing you want to make sure is that you don't have extra junk. So like make sure all the y equals stuff is cleared out. If you had an old equation, go ahead and delete it, okay? Now I'm going to hit, I want to see the graph, just the scatter plot, just so you can kind of get an idea what it looks like. But before instead of just hitting graph and then adjusting the window by hand, they have this really helpful thing. Anytime we enter a scatter plot, our calculator is able to set an appropriate window just by choosing zoom stat. So I'm going to go zoom and option 9, okay? And that's going to tell the calculator, look at L1 and L2, and anything, like any values that are there, make sure they show up on the screen, okay? All right, tell me if you can't get here. I'm going to pause recording for a second. All right, now that we have the scatter plot, our next job is to get the regression equation. So we're going to go stat, and then we're going to go over to calc, and we choose option 4, which is linear regression AX plus B. There's another linear regression down here at option 8. We use that more like in a stats class. but for our purposes, AX plus B is probably the way to go. It wouldn't be wrong to do the other one, but let's just use AX plus B. All right, now we're gonna have some things to enter. First thing I have to ask is, once you pressed enter, did anyone not get this menu right here? Because if you didn't get this menu, we probably need to update your software. It'll help you a little bit. But our job then is this. I want my X values to be L1. Y'all might want to be listening right now. I want my Y values to be L2. That's already set up for me. Now, this is an important step. I want not just to find the equation, but I want the calculator to actually put it in my graphs so that I can actually see it graphed and not have to like by hand copy it over, okay? So I'm going to choose where it says store regression equation. I think it's F4. If we go alpha F4, do I have it right? I sure do. And we choose alpha F4, and then we can choose any place to put it. I'm generally just going to put Y1. Okay. The only reason I would put something other than Y1 is if there was some other equation I was needing, I didn't want to erase that was already in Y1. Okay. Basically, just put Y1. Okay. And then you can go calculate. Yes.
Alpha F4.
F4 is where you get the Y1. Yep.
Alpha trace.
Alpha trace. Yeah.
Oh, thank you.
Yeah. The F keys are along the top. F1 through 5. Choose Y1. All right. And then I'm going to hit calculate. And we're going to get a lot of information here, guys. So let's interpret some of this. Actually, yeah, I'll go to the graph in a second. But we get a lot of information here. First of all, we get an equation. Okay, so the equation, let's see here, would look something like this. It would be y equals, see, it's in the form ax plus b. I'm going to do 0.77. You can go, I suppose 2 decimals probably enough. 7x. B is minus 5.80. That's my equation. Guys, we don't have to worry about r squared, okay? That's something for another class. But r, okay, 0.885. That tells us that we have a pretty strong correlation coefficient, which means essentially that our data and the line are fairly close together, okay? Now remember, what did I say the perfect R value was? 1 or maybe -1, okay? The closer to 1, the better. So a 0.97 is better than a 0.885, okay? Obviously, a 0.999 or a 1.0, better than neither of those. But it's very common to get R values like this. This is still a pretty good, solid number, okay? And if we go to the graph, so I'm just going to hit graph over here, and that's going to show me the line of best fit now. So everybody should have the line of best fit. If you hit the Y equals button, instead of going to the graph, you would see that they've automatically kind of copied the linear equation over 0.77 with a whole bunch more decimals, X minus 5.80 with a whole bunch more decimals. Okay. So right here, I have the scatter plot. I have the line of best fit. And right up here, I wrote the equation. All right. Anybody having calc issues or understanding issues? Do you need explanation? Just drag it off your calculator screen. Yeah, just do a quick sketch, guys. It doesn't have to be perfect. Just do kind of a quick sketch. I'm not going to worry about sketches. I'm not going to grade sketches of your regression work. What I'm going to grade is, it's a couple things. One is, do you have the right equation? And then 2, we're going to go into predictions here in a minute. Are your predictions accurate as well? Okay. So we can use this to approximate a function of basically how many points this individual scores based on the number of minutes they play. You do have to realize, of course, that it's not a perfect line of best fit, right? This right here, kind of far from the line. Up here, fairly far away from the line. But there are going to be moments when it's not perfect, and that's to be expected. Okay. Onward. We have a new problem. We're going to look, anthropologists can use the femur to estimate the height of a human. The table shows the results of a randomly selected sample. All right, these are in centimeters, and we're going to redo our graph, right? So we're going to go to stat and edit. Okay, pro tip, if you want to delete all the data at once without having to individually clear cells, if you go up to where it says L1 and you press clear and then press enter or scroll down, it'll delete the entire column. Now, there's a mistake that sometimes we make. I'm going to do, are you guys watching? I'm going to make a mistake here, right? I'm going to hit delete instead of clear on L2. All right, it's an easy mistake to make. What just happened? L2's gone, okay? So if you accidentally delete a column, it's not gone forever. I'm just going to hit stat. It's a weird thing, but I go to option 5, setup editor, and then I have to press enter and it says done. And you're like, okay, what's that even mean? But then when I go back to stat and edit, L2 has returned. Now I can delete individual cells just by hitting the delete button, but you don't want to delete a whole column that way up at the top where it actually literally deletes the column, not just the entries. All right, so go ahead and enter the femur length is our X value, our independent variable, and then we'll enter the height as our dependent variable. Again, make sure you get the correct numbers in, Ashley, anyone. It's important that we enter the numbers right. It's really tough to get accurate measures if we don't have the right data. By the way, it's probably worth noting, we're doing this as sort of a side lesson. This will not be on your test tomorrow. This will be, well, we'll take a quiz on it. I haven't put it on the board yet. We'll do a quiz over linear regression Wednesday or Thursday. If you practice this, you will get good at it fast. That's my promise. You will remember. You just practice it and it'll be super fast. You just got to know to go to the stat menu. Yep. Okay, just go back to stat. Hit stat. And then edit and then go enter your stuff. Is it in there? All right, guys, I've got my data entered. If I wanted to see the scatter plot, what could I do? I actually don't have to go back to stat plot. I could, but I don't have to because it should already be turned on. I'm just going to y equals. Now, what is this that I already have on y1? What is that business? What's that? It's from the last problem, right? We don't need that. All right, so if I just want to see the scatter plot, I can get rid of the old equation that was there. And then how do I make sure my window is set properly? Do I have to do that by hand? Zoom and go down to option 9, and it will give you a nice clean window for you to work with. All right. It also says to find the correlation coefficient R and the line of best fit. And we'll interpret the slope of the line of best fit in the context of the problem. All right. A little bit to do there. All right. So now we actually have to find our equation, right? So remember, we go stat. Where do I go next? And which one do I choose? And everything is there except I'll have to put y1 in again. So I'm going to go to F4. There is another way to do this, but I think F4 is the easiest way. There is a VARS approach, but I think all of you have the F4 option, so I'm not going to worry about it. And I'm going to press enter. Not only do I have my equation, but I can see the R value is pretty solid. I notice R is not just that it's close to 1, this is sort of redundant, but it's close to 1, but maybe more importantly, I don't know, equally importantly is that it's positive. So saying it's close to 1 sort of gives us 2 bits of important information. Okay, the equation would be y equals 2.91x plus 54.04. My correlation coefficient is 0.986. It didn't say specifically how many decimal places. I would say with the correlation coefficient 3 would be plenty in the vast majority of cases. Okay, and then it also says this, it says to interpret the slope. Guys, what is my slope, first of all? Okay, so the number is 2.91. And I need to think about what that means in context. The slope means for every change in x of 1, our y value changes by this much. So for every, and when you think about it, x value was femur length, right? So for every increase of 1 centimeter in femur length, what's happening? What would we predict based on increasing femur length by 1? Yep. Height increases by 2.9 centimeters. Okay, so the line of best fit, we can use that to look and find the regression equation, but that slope has a specific meaning in context. All right, I'm trying to see, do we have follow-up questions? We sure do. All right, so that's the equation. I haven't even looked at it on my graph yet, right? But I can hit graph and it should be there. It's there. Okay, next, here's where we really need to make sure we're comfortable on the calculator. A man's femur length is 41 centimeters long. Predict the height. Okay, femur length, is that the x value or the y value? That's the first thing we have to think about here. It's the x value. So what I'm going to do is I'm going to hit trace. And now here's the part where we have to be careful. We're not tracing the scatter plot. That's where I'm at right now. Is you see when I press left and right, I'm just going bouncing around from point to point. I want to trace the line, okay? And we can see it here, and I can get kind of close to 41 if I scroll over here. Oh, that's real close to 41, isn't it? But if I want to do 41 exactly, I just type in 41 after I'm tracing and press enter. And so my femur length, I'm gonna drag that screen over here. The man's height would be, let's see, about 173.5 centimeters.
How did you trace the line?
Okay, so I hit to trace the line instead of the points, you hit trace and then press down on the little arrow keys. And if you look at the top, like when I'm tracing, right now it tells me I'm tracing Y1. Right now it tells me I'm tracing the plot. I don't want to test the plot. I want to test the line of best fit. That's what we're trying to use to predict. Okay, the next one works a little different. A man is 210 centimeters tall. Estimate the length of his femur. So it's kind of working backwards, right? 210, the height, is that X value or Y value? So what I'm going to do is I'm going to go into Y equals, and I'm going to type 210. Okay, and I should caution you, I went back for a second to look at the numbers. Notice how the largest number here is 187. What we're doing right here is called extrapolating. And I'll just caution you that it's frowned on in the stats world, okay? We can do it to sort of predict, but once we get outside our range of values, it's a little iffy, okay? So extrapolation, where you predict beyond the values that you have, is a little iffy. Interpolation is when you predict, like what we did on part C. That's a little bit safer. Okay, it doesn't guarantee that the person's 173.5, but it's a pretty good estimate. It's possible the model changes once you get out beyond the points we have. We just don't have that information. Okay, I predict when I hit graph, that's what I thought. I'm not going to see that horizontal line. I just graphed Y equals 210. There should be a horizontal line. Why am I not seeing it? Any ideas? Yeah, my window, if I look at Y max, you see I got like 196. I'm going to change it. I picked 225. I could have done 250, 300, whatever. I just need it to be above 210. Lana, would you mind closing the door? The door stops up top. I think you can reach it. Can you reach it? All right.
Teachers, please be sure to end and keep all hall passes when your students
All right.
to your classroom.
We will end hall
It's really
passes.
important that we are able to verify
All right.
whereabouts today. Thank you.
What I'm looking for then is the intersection of these two lines. I can see my horizontal line now, but I can't see the intersection yet, right? So I'm gonna have to go to window again and increase my X max. I'm honestly just kind of guessing here. I'm gonna hit 60 and see if it's far enough. It is, okay? If you guess and you don't go far enough, just change it again. You're not gonna hurt anything by adjusting the window. And then we've already done this process, but we're gonna find the intersection of those two lines. So my first line is the blue one, my second line is the red one, and the intersection, it says to guess, and there's my answer right there. It's like 53.5. And so we would estimate that the 210 centimeter tall person has a femur length somewhere in the vicinity of 53.5 centimeters. Again, I'm going to put this down here. I'm going to put a caution. This is extrapolation. That's not how you spell it. Extrapolation. Okay, be careful with that. Extrapolation, you can't necessarily just trust those numbers. It's very possible that somewhere off in the future that model is going to change. Maybe people that are particularly tall have a different, like the ratio might change. Maybe their femurs tend to be shorter, maybe they're longer than we would expect, and maybe they're the same. The point is, we just don't know based on the data we have. And honestly, with only a sample set of 8, we might want a little more than that anyway, but that's it. That's a different story. All right, one more. Horsepower of a car versus gas mileage. Where do you guys think I need to start? What's that? Where? I go stat. Which option? Edit. Then I'm going to clear out the old data. Again, I'm going to clear it, not delete it. Okay. And just go back to stat and choose setup editor. All right. Again, that was if you accidentally delete if you go back to stat and choose setup editor, it'll bring your column back, and then you can go do what you meant to do, which was just to get rid of the entries. All right. Again, we should at this point be able to see the scatter plot. There's a chance, again, if I just hit graph, I'm probably not going to see the scatter plot, but if I hit zoom 9, and I don't see it here, but frequently we have situations where we will see extra noise on the like lines and stuff. I'm not seeing extra lines because of the window, but don't forget you've got old stuff in there. So if you might want to go clear the Y1 and the Y2. In this case, it didn't matter too much. All right, this one had a little bit different relationship. Do you see it? Yeah, we have a negative correlation here. Okay, and so a negative correlation isn't going to change our process, but it's just something to keep in mind. As essentially it means as horsepower increases, the gas mileage, that's the other measure, decreases. Okay, as one goes up, the other goes down. I think that sort of makes sense, right? Like if you have a car with more power, you sacrifice efficiency with it. That's sort of the trade-off. It's why like race cars you don't want to you're not going to get good gas mileage on your NASCAR vehicle. Okay, it's just not designed for that. All right, make a scatter plot. Done. I'm dragging it over. Don't you wish you could do that, by the way? Just drag it over and call it. Yep. Zoom 9 should do it. Or I mean, if you hit graph, you can see the graph, but the window's probably not going to be appropriate. All right, next, I need to find the correlation coefficient and the equation. All right, remind me of the process. I want to hear it from you guys. Where do I go next?
I just did it.
Yeah, I'm going to stat, then to calc, option 4. Yeah, by the way, frequency list, just leave that blank. We will, with regression, there must be a reason they have it there, but I'm not sure it would be really rare to use that. Like we don't even use that in AP stats. We use it on some other stuff, but not on linear regression. We want to store it in Y1. That's the screen you should get right there. Like pretty much always, you're going to do that. And that gives us a nice regression equation, and it gives us an R value as well. What part of the R value could you probably predicted before we ever actually did that work? What did we already know R was going to be? How do we know R was going to be negative? Negative correlation, right? The trend is downward. Now, with a little bit more experience, you can look at that and say, it seems like a fairly strong linear fit. This point out here is probably going to mess it up a little bit. If that point were like further left, that might have been a little stronger R value, but still. All right, so our R value is negative 0.916. And then it says the equation. So the equation is negative 0.149 or 15. I'll do 5 x and plus 47.51. By the way, note that the slope is negative. It is not negative 0.916 though, right? Those two things, the R value and the slope, will always have the same sign, but there's not any other connection between them other than the sign, okay? You could have a slope that's really small with an R value that's really strong, or you could have a slope that's really, really big with a really weak R value. Okay. So there's not really any kind of connection between slope and correlation coefficient outside of positive or negative. All right. And we can see, did it say to find the, it said find the correlation, the equation of the line of best fit. And we can see the graph if we just hit graph. I've already zoomed 9 on this, so I should be able to see the graph pretty easily. All right, we're going to do some predictions. 210 horsepower. Guys, was horsepower our input or our output? Our X or our Y? Okay, so all I need to do for a prediction of 210, I should be able to hit trace and just, I have to press down because remember I'm tracing the line, not the points. And I'm going to type in 210 and it gives me my number. What's it doing? I think you're pressing left or right. If you press down, it should toggle between the scatter plot and the line of best fit. All right, so I can look at it in a second. We can, if it's not working on. Our approximation would be about 16.03 miles per gallon. All right, this prediction goes the other way. 26 miles per gallon of fuel efficiency. We want to predict the horsepower. You guys remember how I do it the other way? Go into Y equals. We're going to type in 26. This is interpolation, so it's a lot safer. It doesn't mean that it's a guarantee, but we should be a lot more accurate. And then we can go and just calculate the intersection. And let's see, about 143.5. All right. And I believe that's the end. Yes, it is. All right. So that is that. I'm going to stop recording.